Hello, my name is Isaac, and this here is my boy Basil. And today, we're going to be exploring and understanding our function, which is f at x equals negative 9x to the fourth plus 12x cubed plus 26x squared minus 20x minus 25. Or, in factored form, negative x plus 1 squared times 3x minus 5 squared. Let's begin.
All right, the first topic that we're going to discuss here is the long run behavior of this function using the limit notation. Now, as you can see, this is a degree 4 polynomial. So that must mean that this is a quartic function. Now, all even degree functions have matching long run behavior. So the way you write that is the limit of f at x from x approaching plus or minus infinity equals infinity.
But wait, Basil, since our function has a negative sign in front of that first term, doesn't that make this negative infinity as it's approaching negative infinity from both ends?
You is smart. You a genius. Yes, you are right. Because of the minus sign, this graph is flipped over the x-axis. So that must mean that when x approaches positive negative infinity, it equals negative infinity. Thank you, Isaac.
My pleasure. Now, as you can see, or as Basil mentioned, I should say, this function is quartic. It has a degree 4. All quartic functions can have either 1 or 3 turning points. And as you can see, our function has 1, 2, and 3 turning points.
But Isaac, I have a question. Why can't an even degree function have 0, 2, or even 4 turning points?
Good question, Basil. The reason for that is, like you mentioned, all quartic functions must have matching long-run behavior. And if it doesn't have an odd number of turning points, it will have opposite long-run behavior. Say this function had 0 turning points. This would just keep going, and the long-run behavior would be opposite. Say we took out this turning point right here. It would just keep going up, and it'd have opposite long-run behavior. Therefore, it must have an odd number of turning points. And for quartic functions specifically, it can only have 1 or 3.
All right, I understand that now. Thank you.
Now we're going to be talking about symmetry. As you can probably already tell from our graph, this function does not have any symmetry. But we're going to prove it algebraically. So, for a function to have even degree, or even symmetry, I should say, f at x must equal f at negative x. We already know what f of x is from right here. But what's f of negative x? Well, f of negative x equals, we're going to plug in negative x for each of these x's. So negative 9 times negative x to the fourth plus 12 times negative x cubed plus 26 times negative x squared minus 20 times negative x minus 25. So this is going to equal negative 9 x to the fourth minus 12 x to the third plus 26 x squared plus 20x minus 25. And so you can see that f at x, which is that, does not equal f at negative x, which is this. Therefore, this function does not have even symmetry. But, so for a function to have odd symmetry, f at negative x must equal negative f at x. So let's find out what negative f at x is. Negative f at x equals, and we're going to just switch the signs on all of these by putting a negative in front of the entire thing. So negative 9x to the fourth plus 12x cubed plus 26x squared minus 20x minus 25. Which all of that is going to equal 9x to the fourth minus 12x cubed minus 26x squared plus 20x plus 25. So as you can see, f of negative x does not equal negative f of x, so therefore this function does not have even or odd symmetry. On to you for intercepts, Basil.
All right, now we will talk about what the x and y intercepts of this function is. Now, first we'll start off with the y-intercept, just because that's fairly simple. The way you do it is you have to set f at x to 0, and then solve for the equation. So, f at 0 equals minus 9, 0 to the power of 4 plus 12 times 0 to the power of 3 plus 26 times 0 to the power of 2 minus 20 times 0 minus 25. Now, we all know that 0 to the power of anything is 0, and anything times 0 is 0. So, f at 0 must equal 0 plus 0 plus 0
Plus 0?
minus 0.
Whoa.
It doesn't matter, but let's just keep on,
Sure.
And then minus 25. So, that'll just be f at 0 equals minus 25. So the y-intercept is 0, comma, minus 25. As you can see from our graph here, we are correct.
How about the x-intercepts? How do we find those?
You see, the x-intercept is much more complicated. With this equation here that we have right on top, the minus x to the power of 4, it's really difficult. It's a really nasty equation. What we need to do is that we need to use the factored form of the equation to find the x-intercept. Now, off screen, we had to use some log division and use the factor theorem. And we got minus bracket x plus 1 bracket to the power of 2 times bracket 3x minus 5 to bracket to the power of 2. That is the factored form of this equation. Now, using this, we can easily find the x-intercept. So, for this equation, for this part of the equation, we go x plus 1 equals 0, and that must mean that x equals negative 1. That is our first intercept. It's right here, minus 1 to the power of 0. Minus 1, comma 0. Now the next intercept is 3x minus 5 equals 0. So you have 3x equals 5, and then x equals 5 over 3. That is our second x-intercept, right here. 5 over 3, comma 0. That is our x-intercepts.
There you go. We have explored this function. We've gained a better understanding. So thank you for joining us in Basil and Isaac's Keys to Success.
We hope that you have learned some valuable information that will definitely help you later on in life. Thank you for watching our video.